Yes. So from here, what do we do next? Let's just pick it step after one after the other, and then let's solve. I think that will be more convenient. So let's pick AB. First of all, let's pick AB. So if we pick AB and we want to solve, since AB is in tension, it means that we are still going to just adopt the use of our normal formula. Okay. So the change in length of AB, that is the section one, we are going to adopt a formula such as what? P1 L1 over AE. That is the P1 L1 all over the AE. All over the A1 times. But at the end of the day, we can't say A1 because it is equal for all. Okay. So let's adopt this formula to solve it. Straight away, we can say that what? Our change in length of the bar, 1. So the P we had 50. That is 50 kilonewton or 50,000. 1, 2, 3. Okay. Times the length. The length was given as 600 millimeters. Okay. All over the area which we know is 1,000. The area, what was the area given us? It was given as 1,000. So 1,000 times 1.05 times 10 exponents. 5. Good. So quickly, let's all point this together and let's see the answer we are going to get. Take note, I told you that this guy is in tension, so it will be positive. Okay. So let me put it over here. It's in tension, so it will be positive. Okay. So if I write over here positive, don't get confused. It should also tell you that our answer is going to be affected by a positive sign. So let's all do this together. 50,000 over 60. That is a 50,000 times 600. All over 10,000 times 1.05 times 10 exponents, let's say 5. So at the end of the day, what are we going to get? We are going to get, let's say, 0.28, 0.28, 0.285 7. So let's say 57 millimeters. Good. Let's also do for the other one. So now we can just go and take, let me say BC. Okay, so let's take BC. BC is in compression. So we are taking BC. BC is in compression. So since it's in compression, let's just put the formula down and let's proceed. BC is in compression. As simple as that. So our formula for the change in length we are going to use in this case is going to be, let's say, the load 2. Okay, so P2 times the length, L2. Okay, all over the AE. All over the AE. So let's quickly substitute our parameters into the formula to make life easier. So our change in length of the second material is going to be what? Our P for the second material, the P was 30,000. So 30,000. 30,000 times 1,000. Okay, because we said that 1 meter is equal to 1,000 millimeters. So times 1,000. Okay, all over the area 2 was given as 1,000. The area was given as 1,000 times 1.05, okay, times 10 exponent 5. So finally, what are you going to do? Finally, what are you going to do? Quickly point this and tell me the answer, and let's proceed. So that becomes, what are we getting? What are we getting after trying this? 30,000 times 1,000, which is the length. Okay. All over 1,000 times 1.05 times 10 exponent, let's say 5. And you are going to get, um, but in this case, you should take note that this, we said that this is what? In compression. Okay. So since it's in compression, the negative, it has to affect it throughout like that. Okay. Because of that, our answer is going to be affected, and it's now going to become what? Negative 2, let me say no, negative 0.28. So negative 0.28. Negative 0.2857. Yes, millimeters. 0.2857 millimeters. Let's look at the CD. Let's look at the CD too and see how best we can move. So the CD is also in compression. The CD is also in compression. So you see, our formula still implies our change in length is equal to what? PL. That is, we are doing for the third one. So that is the PL over what? The AE. So quickly, let's substitute our parameters into the formula. Our change in length of material 3 now is going to be what? Quickly. This one, the was given us 10,000. The load was given us 10,000. That is 10 kilo. Okay. Times the length, 1,200. 1,200 all over the area, giving us 1,000, multiplying the elasticity, 1.05 times 10 exponent 3 times 10 exponent 5. Quickly. I told you that this one is also in compression. Since it's in compression, it's going to be affected by the negative I have been putting at the top, as we are all seeing. So that is it. Here is going to be negative. It's also going to be negative. So finally, our answer is going to be what? Negative something. So let's all quickly punch this together. Let's all quickly punch this together. Let's all quickly punch this together. Hey, I can see so many comments in the comment section. That is nice. That is nice. Let's all quickly punch it together. Let's all quickly punch it together. Let's all quickly punch it together. So for this one, I'm getting 0. That is negative 0 point, negative 0 point, let's say 1,143. Okay, 3. So let me say millimeters. So I can now calculate for my total what? Total change in length. Okay. I can now calculate for my total change in length. Quick, and then we go. So finally, my total change in length. My total change in length, as I was saying, according to the formula, is now going to be equal to what? Let's see, let's add all of them. First of all, we said that total change in length, the change in length of material 1. Okay. Minus what? That of the material 2 minus that of, it was only this one that was positive because it was in tension. Okay. Minus the change in length of material 2. So finally, let's just do our substitution to make life much more easier. So the first one we had what? 0.2857. So let me write over here 0.2857. millimeters, oh, minus, and then the other one to 0.2857. So you see 0.2857. Then the last one minus what? 0.1143. So this is 0.1143. So quickly, let's summarize our answer. Let's summarize our answer. So quickly punch all of this on the calculator. 0.2857 minus 0.2857 minus 0.1143. Finally, what are you going to get? What are you going to get as your final answer? I want to take some answers from the comment section. What are you going to get as your final answer? Exactly, exactly. So we are going to get negative 0.1143 millimeters. Millimeters, because even this guy and this guy, they'll cancel each other. So you see, the logic still applies. Mhm. So as simple as that. As simple as that. So this one shows that the change in length that will take, the total change in length that will take place, no, it will rather compress the material. You see, that is why it's being negative over here. So we are done, but let's just look at some past questions within and see how best we can also just analyze them to make life much more easier. Okay, let's see how best we can analyze uh, some also other questions. This question is also quite straightforward. I want the technical ones. Let's pick the technical ones. Let's pick some more technical ones. Let's pick some more technical questions. Look at this question over here. So for these questions too, the load has been provided. Oh, okay. Look at the load. P1 is given as 45. This one, the P1 has been given as 45. Also, P4 has been given as what? The P4 has been given as 130 kilonewton. And then also, which one else again? P3 was given as what? 450. Please, for here, this time we are working together. We just want to analyze some one or two, three diagrams so that if you meet them in exam, you see how to break them down. But for calculation purposes, we are done. So I need your maximum attention and maximum cooperation over here. Okay. This is in kilonewton. They are all in kilonewton. This one is also in kilonewton. Kilonewton. As simple as that. So they say we should determine the total elongation. But if this first one, if you want to draw it, if you want to draw it in three segments and analyze it, how should it become? How should it become like? So let me draw the first one over here, and then let's talk about it. So this is what? AB. This is AB. Now let me put which one over here? Let me put, let's say, BC over here. Let me put BC over here. So this is our BC. This is our BC. You see. Look at the CD. Let me put CD over here. So this is CD. So you see, the A, first one, you have even seen that it is 45. Oh. So this one, you already know that, oh, this one there is in tension already. So this first one is in tension because look at here. If you see here, no, you see that this one is intentional, you should know. So this is all 45, 45. So this will be 45 kilonewton. This is also 45 kilonewton. The last one, let's go and analyze the last one even before we come to the middle one. Look at CD. CD is also in hot tension, as you can see. The arrow is moving away. So this is also 130. This also 130 kilonewton. This also become 130 kilonewton. You see? Uh-huh. They are all in kilonewton, kilonewton, kilonewton like that. You see? Uh-huh. These ones are all in kilonewton like that. So what about the middle one? Can someone tell me what we can do to the middle one to get the answers? Hello, can anyone tell me anything or something about the middle one for on how we are going to
The
get?
middle one is in compression.
Yes, okay, you thank you. So it's in So how do we get the answers for it? How do we get the forces, the answers for the forces around it? Can you tell me how do we get the answers for it? What did I say? Can anyone remember me on whatever I said?
It is negative.
I said that when we talk about vectors, or for vectors, when bodies are moving in the same direction, we add them. But when they are moving in opposite direction, we do what? We subtract them. You see?
Exactly.
Uh-huh. You see, P1 is moving in a different direction. P2 is also moving in a different direction. So if I want to know P2, what do I do? I have to subtract what? I have to subtract P2 from P1 to get my answer of what? P2. But I realize that even in this case, they didn't give any value of P2. So it should tell you that there is a fire on the mountain. Okay. So if that is the case, then let's rather compare what? The CD. Let's rather compare what? CD. Because if we know P3, P2 can also be known. Okay. So if that is the case, what are we going to do? Look at the P4. P4 is moving to a different side. P is moving to the what? East side. P4 is moving to the east side and P3 is moving to the west side, as you can see. So what do we do? Since they're moving in opposite direction, we have to subtract the what? 130 from 450 to get the answer for P3. So everybody, quickly point that and tell me the answer. I want the answer from someone. Someone should quickly point that and tell me the answer. Someone should quickly point that to 450 minus 130. We're going to get 320. Okay. So that answer of 320 should tell you that here is going to be 320 kilonewton. And the other place is also going to be what? 320 kilonewton. As simple as that. The laws of physics are the same for all observers in a uniform motion relative to what? One another. So here is also going to be 320. You see? Uh-huh. Here is also going to be 3. So just as simple as that, as we are seeing over here. And that is what we also did over here to get all these parameters. Over here, you see that they say here is 320. Uh-huh. So don't get confused. That is it. The laws of physics are the same for all observers in a uniform motion relative to what one another. You see, 45 here is 130 and the middle one was 320. The middle one was 320 as you are seeing. So I want to still pick a different one last one, and let's analyze together and let's go. Okay. This ones, as I'm saying, these questions like this, they are very, very simple. It's not anything too difficult like that. But the most technical ones, like a question like this. Let's analyze this one last one and let's go. In let me say about 8 minute time, the link will just go off. Okay, the link will just go off. So let's analyze the last one. Let's analyze this one as the last one, and let's wrap up for today. Are we all together?
Yes, please.
So this one, this
Yes, sir.
let's all mute ourselves and let's just discuss it quick. So first off, I'm going to draw 3 boxes. Okay, I'm going to draw 3 boxes. So this is one. Let me say I put my second one over here. 2. Then let me put a third one over here. 3. So if I want to label the part, this is going to be what? A, B. Then this is going to be what? B, C. Then here is now going to become what? C, D. In physics, we say that if bodies are moving in the same direction, we add them. But if they're moving in opposite direction, what? We subtract them to know their resultant vector. Look at this first one. For A, B, you see that A, the arrow is moving outside. So for this one, since the arrow is moving outside, it means that it is in what? Tension. So I put all of them in what? Tension. I put all of them in tension, straightforward. So here will be what? 60 kilonewton. The other place will also be 60 kilonewton. Here is also going to be 60 kilonewton. So 60 kilonewton, as you are seeing over there. Let's go and do for the last one, even before we can. Here, so you see that the arrows are moving away. So here also means that this one is also in what? Tension. So I put 50 over here and I put 50 over here, even before I come and talk about the last one. So this is 50 kilonewton. This will also become the 50 kilonewton. Okay, so I want someone to tell me the answer for the middle ones. Or I should start mentioning them. Anyone to tell me the answer for the middle one? So for the middle one, so if you take a close look at it, what can you see? The arrows inside are even moving away, right? Since the arrows are moving away, then it means that let's also draw these arrows to move away. As simple as that. Now we look for the forces. Okay, we look for the forces. Look at C and D. C and D are moving in the same direction. Are they not moving in the same direction? Hello? The force at C and the force at D, are they not moving in the same direction? This force
Yeah.
Yes.
and 50 kilonewton, they are all moving towards the east, right?
Yes.
Add them. So at the end of the day, you add them. 30 plus 50 is what? 80.
80.
So it's going to be 80 kilonewton. 80 kilonewton. And then over here to what can you see? Look, I told you that if the forces are moving in the same direction, you add them. 60 plus 20 is going to give you what? It's not 80. So you still write 80 over here. So you see on this note, I continue to say that the laws of physics are the same for all observers in a uniform motion relative to one another. On this note, my name still remains Megabyte the physicist. Don't hesitate to see me in groups, in person, one-on-one, in case you encounter any difficulties with solving any questions or any of the trial questions. Anyway, I've even made life much more easier by even reducing this to its simplest form. Okay, so good students can also do well to take a risk to even solve and send me to confirm the answer for them. It's good to always do that because you may not know the kind of question that may come in the exam. Some of these same questions may be selected randomly and be brought into your exams, and you may not know. So please try to always solve all of them. Let someone help you validate the answer. Yes, you can see our gigapascal over here. You see, you are going to meet it throughout university. This is gigapascal. By this time, I believe we should all know what 1 Pascal is. So that is it. That is it. That is it for today. That is it for today.